Hello, everyone. Good morning. Today is Tuesday, and we're going to be having physics. But before we go into our topic, I'm going to show you a picture of somebody, and I want you to take a wild guess who the person is, and let's see how many of us can figure it out. So I'll tell you some facts about that person as well. Okay, so quick warm up. Yeah. All right. So you would see the picture now. Okay. So guess, take a wild guess. Who is this woman? Who is this woman? You could pause it and think, but let me just go ahead and tell you who the woman is. Okay, her name is Sally Ride. Sally Ride. Okay, Sally Ride. I don't know if you've heard about her, but we're going to be discussing some of her achievements or some of the contributions that she made to the world as we know it today. Okay, so first of all, she did two major things, or she was two major things. She was an astronaut and a physicist. She was an astronaut and a physicist. Yeah. So she was a person that contributed a lot to the concept of space, traveling in space and making, getting new landmarks in space. Then she contributed also a lot to physics. Yeah, to physics as well. So, of course, we cannot discuss all of the work that she has done, but we'll try our best to see, as many as possible. So let's go on and talk about the fact that she was a member of NASA. I think you saw the shirts that she was wearing. It had NASA on it. You could go back if you didn't see what I'm saying. It had NASA written on it, so she was a member of NASA. And I think we've all heard of NASA. If you haven't, or if you've heard of them but you don't really know, what it's all about or what they do, you should Google it. It's very important. You need to know, the immense work they've been doing and the immense contributions they made to, space and the study of space as a whole. Okay, so she was a member of NASA, and guess what? She was the first woman, first American woman actually, to go to space as a crew member on the Space Shuttle Challenger. So I want to say that's a very, very great feat, because being the first person, among a set of people makes you the way paver, in the sense that you pave the way for others to follow, to also accomplish that feat, after you've done that. So I don't know, probably you have some things that you want to achieve and nobody else has done them. Yeah, you could be the first to do it. You could be the first if you just keep believing and you keep channeling your energy to, and putting in the work that particular goal requires. So yeah, I like people who have done things first. But even if, there are other scientists that haven't been the first to do something, but they have contributed in their own way as well. Now, this is the last one we look at here. She was the only person to serve on both of the panels investigating shuttle accidents. Now, as much as we love space travel and we like the abstract idea of, thinking about the fact that somebody is in space and all, there are some, casualties that could occur. The same way you have, car accidents or flight accidents. They are not, it's not something people really, nobody looks forward to it and nobody likes to encounter it, but they happen. So, sometimes they need to investigate the cause of that accident. What was it, negligence or something beyond anyone's control, So she was on both of the panels that investigated the Challenger accident and the Columbia disaster. So I think she was a very important woman. Yeah. So let's look at, this is where I'm actually going. Let's look at her legacy. What was her legacy? What did she leave behind? After she left, what did she leave behind? Now, she co-founded Sally Ride Science. The company is actually named after her, Sally Ride Science. That was as a 2001. So you can see she's not necessarily an aged scientist that lived in the maybe 20 BCs or 30 BC. She lived in our time, and she was the president and CEO of Sally Ride Science. Now, I'm I'm sure you're probably wondering, what's Sally Ride Science? What's it all about? Now, guess what? This company creates not just informative programs or educative programs, entertaining science programs. You know, that minute where you're doing science, but you are enjoying yourself, you're having some fun. Just take a look at these girls. I'm sure they are enjoying themselves right, right there. Okay, so the major focus anyway, the company focuses a lot on girls, to encourage them to go into science, to love science, to make, to do great things, to make great feats, to accomplish unimaginable things, right? So she was the first American woman. We mentioned that to go to space on, as a crew member. Then she decided that, oh well, I want to give this opportunity that I got, or this great feat that I accomplished. I want others after me to do the same. So she established this. Isn't that amazing? Isn't that amazing? Even after she has gone, her work lives after her. Okay, so that's Sally Ride. Now let's go into our topic. Okay, so first of all, let me tell you what you would know if you pay attention, if you pay close attention to our discussion today. Now, number one, whenever you hear the concept vertical projection after today, you would have a good idea what it's all about. You would be able to get a firm grasp of what is being discussed. And then for horizontal projection as well, whenever you hear or see horizontal projections, you'll be able to say, okay, this is what it is. Then you would also be able to solve problems. I will give some examples, maybe one or two examples, and you would also be able to solve problems applying the knowledge that you have received from the solution of the examples. So I need you to pay close attention. Okay, I need you to pay close attention. Now, our topic is motion under gravity. Motion under gravity. Now, we're not just dealing with motion. We've talked about equations of motion prior to this time, where we talked about different types of motion. Yeah. Now, we're not just dealing with motion now. We're studying how gravity affects the motion of bodies. And of course, it's a very wide field. I know you've heard gravity. Can you say gravity? Yeah, I know you've heard gravity. You've heard about that concept before. Now, we want to talk about how it affects motion, the motion of bodies. Okay? So, but before we go into that, I want us to recall something quickly. If you haven't watched this video for equations of motion, we did it some weeks back. So you could go back and watch that video. It's very important. So, but if you have done that already, you could recall these formulas for equations, the equations of motion. So we have V equals CU plus AT. We have one for S, which is distance, and we have another one, V square equals U square plus 2AS. And then we had a supplementary equation that we were using, to derive others. So that's the last one there. So if you recall these formulas, kudos to you. If you watch the video and you don't recall, oh, I feel so heartbroken. You need to practice. You need to keep these formulas, and we talked about how to derive them, so you need to keep them, upstairs. Okay, so let's try our best to be determined and be focused. Now let's go on and discuss. Oh, I'm so excited to discuss gravity. Yeah, we talked about Isaac Newton one time. When I was telling you fun facts in physics, our section on fun facts in physics, we talked about Isaac Newton, and we said how he helped us a lot with gravity. Right, so if you remember that, you have an idea already what gravity means. Okay, but gravity is a phenomenon, among so many other phenomena in physics, that talks about how all things that have. Now, when I say all things, like, it can mean human beings, it can mean objects, it can mean anything. So anything that has mass or energy, gravity describes how those things are brought toward one another. Okay, for example, you throw a ball upwards and it comes down. What brings it down? Have you thought about that? What brings it down? Gravity. You throw your pen up and it comes down. What brings it down? Gravity. You jump up and you come back down. You're not suspended in the air. Okay, that's also gravity. We just have a few, we have a few, should I say, objects, not necessarily objects, a few things, okay, that can overcome that gravity, like birds. And we also use that application of the escape velocity to talk about how rockets and other things work. But that's a topic for another day. Today we're going to be focused on how this gravity affects the motion of the body. How does it affect the motion of the body? Now, the one concept you need to understand is the fact that this gravity results in an acceleration, which we refer to now as the acceleration due to gravity. It's called G. It's approximately 10 meters per second square. You could also say 9.8, So these are the approximate values for acceleration due to gravity. Now, so you remember those equations I just showed you in the previous slide? They turn into something else. Instead of A, A stands for uniform acceleration, when we're talking about normal motion of a body on a straight line. Now, instead of A, we're going to be dealing with G, that's acceleration due to gravity now. And then instead of S, we're talking about distance in those other cases, we're going to be dealing with H now, which is the height. Okay, the height. It could be the vertical height, it could be the horizontal height, or should I say horizontal range. We'll get into that, okay? So our equations become this. Like I said, all the A's have been replaced with G, and all the S's have been replaced with H. Okay, so our equations look like this. Now, but you notice that apart from that replacement, there seems to be a modification in the signs. So instead of plus, I have plus or minus now in each of these equations. Why? Can you think about it? Why? Why do we have plus or minus in each of these equations? Okay, let me tell you. Now, when a body is thrown upwards, for example, so it's thrown upwards, what happens? The gravity seeks to pull that body down, right? So that means we could say that the body thrown upwards is working against gravity. It's going against gravity. It's trying to challenge gravity. It's saying, gravity can bring me down, or something like that. The body is working against gravity. It's telling gravity, no, I'm going upwards. You're not going to pull me down, right? So it's going in the negative direction. So we say that the upward motion is negative. So we take the negative component of those formulas to use for solving upward motion. Okay, but when a body is moving downwards, it's probably saying, oh, I've accepted that gravity is just going to pull me down, so I might as well just go down down to the ground, right? So when a body is moving downwards, in essence, it's working in the same direction as gravity. So yeah, you take the positive component of that of those equations. So downward motion is regarded as positive. It's very important that you understand this because it will determine the formula you would be using. So let's go on. Now let's talk about vertical projection. Vertical projection. When you hear the word vertical, what comes to your mind? Vertical, what comes to your mind? Now vertical has to do with going from, running from up down or running from down upwards on a straight line, either from going from the top to the bottom or from the bottom to the top. So a straight line. In mathematics, the vertical is the y-axis, if you remember your graphs, right? Now, when we talk about vertical projection, what are we discussing? Now, if an object is thrown vertically upwards, if you throw a ball, you can practicalize this. You could stand up and practicalize this as I'm talking. If you throw a ball vertically upwards or any object vertically upwards, as it goes up, the speed reduces. It slows down. It slows down as it goes up. You throw it with a velocity, a force and a velocity at the start. You throw it up. And then as it goes up, it slows down. Why does it slow down? You can see in bracket, I put gravity. So yeah, Mr. Gravity is at it again. He's slowing people down, trying to bring them down. As you threw that ball up, gravity was like, oh no, he's coming down. So as it goes up, it starts to slow down, and then it comes to a stop for a split second, for a very short moment. It stops momentarily, and then it begins falling. And guess what? When it starts to fall, it falls fast. Because gravity it's now going in the same direction as gravity, so gravity has all the energy to pull it down. So when it starts dropping again, it falls quite fast. Now let me show you a diagram of something of what I'm trying to say. Now this is a woman. She threw this ball up. Now the maximum height, we want to analyze everything that is involved here. The maximum height the ball reached is this this distance, the maximum height from where she threw the ball to the top point where the ball reached, that's the maximum height. We usually call it H max. Okay, H max. Now, the initial velocity of the ball is u. Okay, when the ball was going up, the woman used a particular velocity. Okay, she threw it up with a particular velocity, with particular speed, and that is what we call u. Now, the higher or the greater the speed, or the greater the velocity with which the woman propels that ball up, determines the height that the ball will actually reach. Try it out. Use a little force and throw a ball up, and then use a lot of force and throw the ball up. You see that the more, the higher the velocity or the higher the force you apply to the ball, the higher the distance that it would reach, or the height that it would reach. Okay, that's just something I want you to know. Then, of course, we have the acceleration due to gravity, g, trying to pull this ball down. No, gravity never gives up. Gravity never gives up, except you get to a place where there is no gravity. On Earth here, there is acceleration due to gravity acting downwards. Okay, then we have the final velocity, and I put here that the final velocity is 0. So why do you think the final velocity, I mean at that height, why is the final velocity 0? Why is it 0? I think we talked about it previously, and we said the ball momentarily comes to a stop. Remember that we said that? Yes, so the final velocity at that height, just before it starts to come back down, at that height, the final velocity is 0. Okay, all these things are very important. It's important that you understand them. So the ball starts to come down again after that. It starts to come down. Now, if you want to get let's assume you were asked to find the maximum height the ball has reached. What do? Let's look at that now. Let's look at that. Remember this formula? So we use v square equals u square minus 2gh. We can replace our h with h max, since it's the maximum height we're looking for. Remember I said for upward motion it's going to be negative, so you can see the minus there. So then we could manipulate. Let's do a little mathematics here, So let's do mathematics by substituting. Remember our v is 0. We talked about y, and then you substitute 0 and you have 0 equals u square minus 2gh max. And then you do some manipulation and you either say you add 2gh max to both sides, or I could say I'll just take this 2gh to the other side and it becomes positive. So 2gh max equals to u square, right? Now I need to get h max. Where do I practically change in the subject of the formula? It's a topic in mathematics. I hope you've done it, okay? So we're going to divide both sides by 2g now to get our h max. And our h max would be u square over 2g. It's as easy as that. So as time goes on, you could just be using this formula to get the maximum height. H max equals u square over 2g. Okay, let's move on. So we're still on vertical projection. Now, if you want to find the time taken to attain this maximum height, so the woman throws the ball up and then she says, I want to know how many seconds would it take this ball to get to that height? Okay, so if you want to get the time, remember this formula, v equals to u minus gt. Okay, now remember that v is 0. We already stated that categorically in the last slide. So v is 0. Let's do some mathematics again. Let's substitute. Follow me. So yeah, you could try this out. Write it down on your own and see if you're getting me. So we get 0 equals to u minus gt, and then I could add gt to both sides, or I could say I'll take minus gt to the other side. It becomes gt equals u. And then we can get t by dividing both sides by g. So t equals u over g. So the time taken to get to that maximum height depends on the initial velocity and the acceleration due to gravity. So t equals u over g. Okay, then there's something we need to get again. Conversely, time of flight, t, that's capital T now, is 2 times the time taken to reach the maximum height. Why? Can you answer that question? Why? Now, let me just tell you that time of flight, when we say time of flight, the time of flight simply means the time taken to get to the maximum height and return back to the ground. In this case, and return back to the woman's hands. You know, she's going to catch the ball. So the time taken to reach the maximum height and go on the return journey back down is what we refer to as the time of flight. So of course, it's going to be 2 times the initial time taken to go up. Okay, it's going to be 2 times that time. So that's why we said 2t, because you're looking at both the time taken to reach the maximum height and the time taken to come back down. All right, so let's move on to substitute, and we have 2t would be 2u. You know, t is u over g, remember that? So we can just multiply that by 2u over g. So that is the time of flight. Yeah, that's the time of flight. So we have formulas for the maximum height, the time taken to reach the maximum height, and the time of flight. Try to remember all of these formulas, okay? Now let's take an example and let's see how many of us have been following. So a tennis ball is thrown vertically upwards from the ground with a velocity, okay, no, with a velocity, this shouldn't be here, with a velocity of 40 meters per second. Calculate the maximum height reached, the time to reach the maximum height, and the time of flight. Calculate the maximum height reached, the time to reach the maximum height, and the time of flight. Okay, so what do we do here? What do we need to do here? All right, so let's take a look at what to do. First of all, I usually say all your parameters should be well written out, you know, to make your work easy. List out what you've been given. Since the ball is thrown vertically upwards from the ground, that means the initial velocity is 40 meters per second. So I'll write u equals to 40. All right. Then we have already said this over and over, that the final velocity at the maximum height will be 0, right? So I would also note that. You would not be told that, but you should know, you know, after constant practice and solving different examples, you would remember that, okay, v is 0. Then we are to find h. So let's see what we can do. Of course, g, if you're not given acceleration due to gravity, if it's not specified, you could just make use of 10 meters per second square, or you could use 9.8 meters per second square. But when it's specified, you need to stick with what you have been given, okay? So I'm going to use 10 here, and this is what I'm going to do. Our formula is h max equals u square over 2g. So that would give us, if this is our formula, u square over 2g, I would then substitute u as 40 here, 40 square, over 2 times 10. Okay? So now, if we do 40 square, we should have 1,600. 2 times 10 will give us 20. So if you divide that, you should have 80 meters. Okay? If you divide that properly, you would have 80 meters. Please try it out. Write it on a paper and a pen. Use a pen and see what you would get as well. Okay. Then the second part of the question says we should find. Okay, I'm going to also leave all the parameters here for you to see. Now the second part says find the time to reach the maximum height. Let's go back and bring our formula. What was our formula? Okay, t equals u over g. Oh, that's a simple one. 40 over 10, right? And 40 over 10 is 4. So 4 seconds. So it takes 4 seconds to reach the maximum height. And then the time of flight, that's an easy one as well. Remember that the time of flight is 2 times of the time taken to reach the maximum height. So we could just say 2t, you could say 2 u over g as well. But you could say 2t and just do 2 times 4. Okay, but I'm using t equals to 2u over g. So 2 times 40 over 10, and that gives us 8 seconds. So take a while to digest this. You could rewind, you could replay, as long as it takes you. Now let's go on to the horizontal projection. Now when you say horizontal, what's the horizontal? The horizontal is usually a plane ground from left to right. When we are representing it, if we want to represent it on a line, we would draw a line going from left to right. Okay, in mathematics, the horizontal is the x-axis, the horizontal axis is the x-axis. So when we say horizontal projection, we're simply talking about a ball or an object that is thrown horizontally this time and not vertically. Okay, let's see how this can be applied. So let us take a look at the direction of motion of a ball projected horizontally from a particular height, h. So you can see this diagram. Look at this diagram. Okay, and you can see that ball. The direction of projection is usually half of a parabola. The curve it traces out is usually half of a parabola. I don't know if you've heard of a parabola, but that's something you would probably do if you haven't already done it. So the ball is projected horizontally, but at a point, even when you project it horizontally, it's still going to touch the ground, right? That's the force of gravity. Gravity is wonderful, right? It's wonderful. Not all things that pull you to the ground are evil. So gravity is not evil per se, because it keeps us sane. It keeps the world, balanced. Okay. So, or just imagine, what if you jumped up one day and you couldn't come back down? Yeah. So you should not see gravity as an enemy. So let's get a formula for the height of this projection, the h there. Let's get a formula for that. Now remember this formula. If you remember this formula, initial velocity here is going to be 0. Why is it 0? Because in the vertical direction, there is no velocity. The ball is projected horizontally, so of course there's no velocity for the vertical direction. So our initial velocity in the vertical direction is 0. So that means automatically I can say h equals half gt squared. H equals half gt squared. Now there's a difference between horizontal and vertical projection. I want you to be careful not to mix them up. I mean the formulas, okay? So let's look at the next one we're going to look at. Now also, since h is half gt squared, that means that 2h, if we cross multiply here, or you could multiply both sides by 2 to make your work easy, you would have 2h equals gt squared, and then t squared would be 2h over g. So automatically t would be square root. We're just doing change of subject here, okay? So t squared will be 2h over g, and t will be square root of 2h over g. Okay, so this is the time taken, to cover that height. Okay, now we also have what we refer to as the range. Now the distance, the horizontal distance covered is what we refer to as the range, and we call it r. So how do we get that distance, that range? We could use this formula as well. H equals ut plus half gt squared. Right, we're using that formula as well. But instead of writing h now, rather, we would put r. We would write r. Okay, so, but another thing you need to understand is that along the horizontal, there's no room for gravity. If it's a vertical, is a vertical projection, if the ball is going up or the ball is going down, then you could say gravity is acting on it. But if it's horizontal, then we cannot state that g would be present. So this whole thing, half gt squared, becomes 0. Okay, becomes 0. So in that case now, r becomes ut. So remember I said instead of h, we're going to put r. So our r is ut. Okay, and t is 2h over g. So our r will be root 2h over g. So our r will be u times square root of 2h over g. Okay, so let's move on and let's see something else that might be, more interesting for you. So let's take this example. So another example on horizontal projection. Now a ball is thrown horizontally with a velocity of 20 meters per second from the top of a tower. The tower is 80 meters high. How far from the foot of the tower will the ball touch the ground? So we are saying what distance will be between the point where the ball touches the ground and the foot of the tower. So can you figure out what we are actually looking for? From what I just said, we are looking for the distance between the foot of the tower and the point where the ball touches the ground. So what are we looking for? Think about it for a second. Okay, let me tell you if you've been able to think. We are looking for the range. Remember, okay, let me go back a bit. Remember that the range is the distance from, this is the height. It might be a tower, it might be a building, it might be anything. So the range is the distance from this point to this point where the ball has reached the ground. So in this case, automatically, what they're actually asking you for is the range. But we won't just go straight into that. We're going to list out our parameters first. So we have U as 20 meters per second. We have H as 80 meters. We have our R that we are to find. Okay, now you've been given G as 10 meters per second square. So our R, remember this formula? Remember. You need to learn these formulas and be familiar with them, okay? So R equals U times square root of 2H over G. So we will just do some mathematics and do some substitution here. So 20 times square root of 2 times 80 over 10. Now, if you do this properly, you would get 20 times, 80 times 2 is 160, divided by 10, 16. So 20 times square root of 16, and square root of 16 is 4. So 20 times 4 would give us 80 meters. So that's the range. That's the range that will be covered by that ball, the horizontal range. Okay, so let's go to one more thing, then we'll call it a day. So resultant velocity of a projectile. Now, we have the vertical component and the horizontal component of any projectile. So it has two major components. That's the velocity. So we have the horizontal component U and the vertical component GT. Remember that when you're dealing with the vertical component, okay, U would also be 0 because there's no velocity in the vertical direction. There's no initial velocity in the vertical direction since the ball is propelled horizontally. Okay, so this is how it will look like. To get the resultant velocity, you just need to do V equals to square root of the horizontal components all squared and the vertical component all squared. So this is how your resultant velocity would look like. Now, of course, you could take some questions and just task yourself on this and see if you could apply that formula as well. So I want us to take a quick summary of what we've done. We haven't done too much. We've talked about the vertical projection, and how gravity works in that scenario, and we've talked about the horizontal projection and how gravity affects the motion in that case. Now, you need to understand that gravity on its own is a whole field. It's a new field, or not a new field, rather a wide field and a topic on its own. So in another class, we're going to focus solely on gravity. We'll talk about maybe the gravitational field, the force in a gravitational field as well. But that would be in another class. So today we've looked at the formulas we can use as well to solve problems that have to do with vertical and horizontal projections. Okay? All right. Now, I have something for you. Yes. So try this out. It's important that you practice, after watching the video, or after you've been taught a topic in class, or wherever you find yourself. It's important that you practice. They say practice makes perfect, and it's the truth, to be honest. So try this question, then you could define this and state their formulas as well. Okay? From the video, you can always get the answer. But I also want you to research. Find out more things that you might not have seen here. Just think outside the box and find out. Do more research on vertical projection, on horizontal projection. And I want to hear back from you. Tell me more than I have given to you. Give me back more than I have given to you. Okay? So I'll be looking out for your comments in the comment section. Okay? And then lastly, you can visit quizzes.com and see if you can check out if there's any game on motion under gravity. Or you could just go online as well and get some other questions apart from these questions I've given you. So it's very, very, very important that you practice. Okay, so that brings us to the end of our class today. Don't forget to check a lot more on Sally Ride if you can, and I'll see you guys in our next class. Remember to subscribe if you haven't. Tell your friends, share the video to your friends. You could like it, you could comment, leave me a comment. I really, really, really love to hear from you. Okay, so today our class has come to an end. I wish you the best of luck in the rest of your activities today. Do have a lovely day. All right.